the sort of, like here's a rough outline of what I'm planning to talk about. So we'll begin with some introductory remarks, and then we'll go into a particular sort of model of debt that we've been sort of discussing lately. And then I'll talk a little bit about sort of economies, what I call economies of endless repetition, and then finally we'll come to the question of the Great Divide, and then hopefully, if we have enough time, we'll end with the question of education. So I also want to keep sort of the my presentation part short enough so that we have enough time for discussions, because I think it would be great to have discussions rather than sort of one person speaking single-handedly. But I'll try my best to sort of keep it short. Okay, so the first, like whenever we talk about mathematics, right? There are certain issues that in a way crop up immediately, and so I thought it's important to maybe get those out of the way so that at least for the purpose of this discussion, we are on a common minimal ground of understanding, shared understanding. So what I mean by that is that when I think about mathematical sciences, I think of it as social sort of, it's a social activity, it's a social enterprise, which is we want to think of it as sort of mathematics as something that people do, right? As opposed to an abstract body of knowledge that sort of exists on its own, because obviously that's not the case, right? So we want to think of mathematics as basically a part of social process, right? So that's what I mean by the what you see here, mathematical sciences as a social cauldron of imaginations and realities, a cauldron, a mixture, a cauldron of, like, let's say, of sports, economics, absurdities, thought experiments, religions, technologies, and so on. Hopefully we'll get to see a glimpse of what I mean by this through the discussion. So here is, this is a quote from Thomas Levinson's sort of recent book. Like, I think it came out this year or maybe just ended last year. It's called Money for Nothing. The scientists, fraudsters, and corrupt politicians who reinvented money, panicked the nation, and made the world rich. So that's the book, and I'll kind of keep quoting from this book every now and then. So here is the first quote from the book. So Levinson writes that the history of scientific revolution is usually told as a sequence of discoveries, mostly in mathematics and physics. That picture leaves out a central human fact. Those who solved problems of planetary motion or the flight of cannonballs did not confine themselves to natural philosophy, right? So that's sort of the that's the first point, which sort of, in a way, what it leads us to think about, may describe as.
Can't hear you. Can't hear you, Tata.
Can no one hear me?
No.
No, I cannot.
Can't hear you.
Hello, can you hear me now?
I'm not hearing anything. I sent an email to Tapan and ITKM.
Sata, sometimes what happens is if you take off your earphones and it might actually work. If you take off your earphones, I mean, you might have your own, your laptop has a direct mic, and I don't use headphones. Sometimes that works better. My God.
Jayasri, could you call him? I think maybe he's.
No, he said, no, he just said that he's going to actually use your phone. I shouldn't want to call him. He said that he's going to connect via his phone.
Okay.
Hello.
Yeah. Okay.
Okay, this is audible, huh?
Yeah.
Okay, so I'll keep my both the logins. I'll use my slides from the laptop and speak from here. That works, right? So I mean, did you was it like completely blank? On
No.
this file? They kept speaking.
No one could see and one could hear you. No, when I couldn't hear, I told you.
Okay, fine. All right, so and you can still see my presentation, right?
Yeah.
Okay, great. All right, let's see where we were. Yeah.
So you did talk about this.
We talked about this. Yeah. So right. So basically, it kind of what this means is let me just backtrack a bit. Yeah. So when we talk about mathematical sciences as being social, right? So one of the things, therefore, that means is if you want to go beyond like the usual typical history of mathematics, which is or scientific revolution, which is usually told as a sequence of physical discoveries and so on. I mean, what it in part means is that we need to get into some we need to talk about what we might call as the mathematics of material experience and change. So this is another sort of quote from Levinson. He says, so this was, I mean, so Levinson's book basically begins with Isaac Newton. Like, I mean, we need to sort of, like, if you're talking about like modern science, what we mean by modern science, there's no escaping this person, right? So, so Levinson talks about, how, so during, I mean, so this is like during the early years of Newton's research, he realized that Newton began with sort of, like the calculus of motions, and but then over over time, Newton realized that this approach, this generation of figures by motion, right? That's essentially one of Newton's central contributions to this, right? I mean, we'll come back to that in a bit. But like this generation of figures by motion could apply not just to abstract travel, taken together by abstract travel here basically means sort of the, it's as if the mathematician is sort of traveling along the curve that is generated by an equation and so on, right? Let's say a parabola or whatever. So Newton realized that this could apply not just to the abstract level, but even to real life, right? So, and then sort of he kind of goes on to sort of, develop the mathematics of calculus. And then taken together, those two interrelated ideas here, I mean, these two ideas here refer to differential calculus and integral calculus. These two interrelated ideas, as developed and extended, remain the foundational mathematics of material experience, right? So this is, I've kind of lifted this phase of this mathematics of material experience from Levinson. What this means is applying numbers to a concrete question. For Newton, the primary question was the initial question was, why does stuff stick to our planet's surface, right? Even while the planet is moving using constant motion. So applying numbers to a concrete question transformed the pure mathematical reasoning within his calculus into a literally down-to-earth experience. Newton's work now became one of the early examples of what you would call a mathematical model. Right? So that's just a clarification of those interrelated ideas. So this is sort of, just like this is a familiar story. Now, but we want to sort of focus on, if you remember the initial slide, the one we began with, right? I mean, the kind of like how the usual history of scientific revolutions leaves out certain central facts of human existence, right? So one central fact that is often left out is this. That Newton was not just, although he began his life as a physicist, that's not the only thing he did, right? I mean, like eventually Newton, in fact, became the master of the Royal Mint of London, right? So Levinson writes, there in rooms built along the outer wall of the Tower of London, Sir Isaac Newton, master of the Royal Mint, produced Britain's supply of the real money. Gold and silver bullion of precisely defined and authenticated purity, rolled and punched and stamped into discs of legally mandated weight, decorated with the head of the king. He had been advising the crown on monetary matters since the mid-1690s. And by this time, he was an experienced stock market player on his own account, which included at this moment a tidy sum in South Sea stock. South Sea Trading Company was one of the trading companies. We'll come back to South Sea in a bit. The point I wanted to also point out here is that it's in the 1690s. It's right at this point of time, the mid 1690s, when the Bank of England came into being, right? So Newton was not just sort of some administrator of a mint, but he was in fact a pioneer of modern banking as we know it. I mean, he was not the only guy, but like he was part of that bunch of guys. So here is a coin that one of the coins that have been coined, minted in memory of this. So 5 pounds. Okay, so this kind of brings us to Newton's work on the theory of money, in particular, what we might call the mechanics of money, right? So Newton sort of, argued, and again, I should point out that this is not just Newton, but this was kind of beginning to sort of, starting to become the mainstream scientific wisdom or economic wisdom of those times in a particular area, right? I mean, in a particular geographical location. So money was considered as a stream of income, a system that evolves over time, which means what? Which means that any system that evolves over time is expected to sort of lend itself to inquiries through the calculus of mechanics, right? So calculus of motion. Not surprisingly, therefore, that Halley, Edmund Halley, Newton, these kinds of people, when they were interpreting and they sort of began to use mathematical models to interpret and manipulate money supply and income and the mechanics of money, right? Now this wasn't a smooth sailing. So there were a bunch of competing theories on this. In particular, there were two main strands that we can find. So according to Newton, money basically, I mean, so if you take like a gold coin, right? I mean, so the gold coin has basically two kinds of values, right? One is sort of the amount of actual gold it has, and the other value that it has is what we might call as the fiat value, right? I mean, so the kind of amount of stuff that you can buy with that gold coin, right? And this has been a constant sort of crisis in terms of defining value of money ever since, right? I mean, what is the value of a coin, right? According to Newton, we value money because with it we can purchase all sorts of commodities, and the same. So basically, the value of money in essence is just a matter of opinion, right? So therefore, Newton says that it is mere opinion that sets a value on money, and the same opinion sets a like value upon paper security. So Newton didn't make a difference, was not ready to make a difference between metal money and paper security, like let's say government bonds and stocks and this kind of thing. On the other hand, the other competing sort of approach was the one that was taken by Pollexfen, but also most famously by John Locke, who, although being a sort of a colleague of Newton, and in fact sort of an assistant of Newton in the main, in this case was an adversary of Newton, right? So Locke or people like Pollexfen, they subscribe to what you might want to call the nominal metallic value of money, right? I mean, so that the value of gold, a gold coin, is exactly equal to the amount of gold it has, right? So this there was a clash, right? I mean, but it's important to point out also that this is not a clash. This is not just a theoretical clash, right? This is not just a sort of metaphysical clash. It's in fact an economic. I mean, it's a clash of economic interests, right? I mean, and it's a clash of economic interests between rent seekers and merchants, because uh, what happens in terms of um, well, I mean, this is kind of related to sort of the questions of devaluing money and so on. Every time your metal supply, etc., starts to falter or whatever, something arbitrage happens and money dries out from your economy, etc. That's when these kinds of things happen, right? Now, the thing about by rent seekers, I mean landlords and the government, like people who collect rents and taxes and so on, right? So for such people, it is important to sort of claim that it's important to ensure that let's say if you have like a box full of golden coins, and tomorrow your government devalues the value of those coins by saying that, oh, tomorrow onwards we declare the value of this gold coin to be half of the value that it was till yesterday. What that really means is that people who have people who have collected these kinds of rent, including the government themselves, will lose out on that money, right? They will lose out on that value. So it was primarily sort of the landlords and sort of people who sort parts of the government bureaucracy who were sort of hung up on who were like serious about like tax collection as the primary form of rent collection. They were sort of they were the ones who were who were fighting for establishing the value of metal currency on the value of the metal it contains. Whereas when it comes to merchants, if you're a trader, right, if you're a merchant, you can't operate like that, right? I mean, you need to have your most of your business, like particularly overseas business and so on, is going to be dependent on sort of lending out money, like on basically debt relations, on bonds and on stocks and so on, right? So in other words, paper security, right? So this battle between Isaac Newton and John Locke, in a sense, reflects in certain ways the kind of struggles that were going on in 17th century England between sort of the rent collecting classes and the merchants, right? The merchant lobbies. Okay. So Newton says, for instance, that if interest is not yet low enough for the advantage of trade and the design of setting the poor on work and encouragement of all such business as is profitable to the nation, the only proper way to lower it is more paper credit, till by trading and business we can get more money, right? So Newton is arguing that paper credit is essential if you want to run an economy which is based on sort of trade and as he says, quoting him, setting the poor on work, right? Because you get the connection here is that, like, I mean, how do you get someone to work on your plantations? First of all, you get them indebted, right? I mean, you get them into debt bondage, and then you convert them into sort of either sort of, serfs, and then eventually into wage earners, right? I mean, even in today's world, like, let's say in our wage economy, most people who do like these 9-to-5 jobs, right? I mean, these wage earning jobs and, that involve backbreaking labor, most of them are bound to do it, are forced to do it basically because they have loans to pay off, they have debts to pay off. Right? So that's so anyhow. So I mean, it's kind of interesting. I mean, like, I encourage all of us to sort of go back and sort of go through this history. It's interesting how all of this, I mean, this is happening while Newton was sort of the master of the mint and sort of the chief economic advisor to the government. And also, like, by this time he was like really famous as one of the most influential scientists around. But however, this is what it led to. I mean, this is the famous South Sea bubble. So this is the South Sea bubble is the first major financial blow up in history. Here you can see the graph of what happened to the London Stock Exchange when this bubble burst. And as you can see, it happened it took place between 1718 and 1721. And I mean, we can go into go into a lot of details about the South Sea trade itself, but I'll just say here that it's an intriguing story of political fraud, insider trading, slave trade. It was basically a slave trading company that was entrusted by the British Crown to sort of capture slaves from what we today call the South Pacific, right? I mean, so and transport them, right? So yeah. So okay. So Newton. So this is interesting because like Newton is not only sort of devising the government monetary policies, but he himself is a sort of investor in this South Sea company. And basically by the end of this, Newton goes flat broke, right? I mean, as you can see in this graph. Okay. So, but this is. I should say that this is not just about money. I mean, money here is an example, an important example, but still an example. What I really mean is that this has been the story since 1700s. This has been the story about basically anything about our material existence that could be observed, measured, and counted. Right. So when you think about money, I want us to sort of think about money as an example of something that fits this, right? I mean, that can be observed, measured, and counted. So this is what, and that in a sense, this kind of was the beginning of what we can call the centuries of mechanical mass production, right? I mean, mass reproduction. So, and we'll again come back to this in a while. Or in other words, this is also being called the age of clockwork machines, right? Or the clockwork universe. So that's sort of the 1700s. Now, what we let's skip a bunch of centuries and let's come to today, right? So today what we have is, if you look at, so one of the things, I mean, if you go back to Newtonian mechanics, right? I mean, why is Newton, one of the main reasons, what things that sparks off like the Newtonian mechanical paradigm is the fact that we are talking about a society or an economy which is mechanizing, right? I mean, so this is sort of getting like for various kinds of political, economic, geopolitical reasons, we are seeing a shift, a fundamental radical shift from what was earlier much more like human labor-based feudal economy, which that itself was, of course, a kind of an evolved stage of the earlier Roman slavery-based economy. In any case, for various reasons, what we see as happening around 1700s is actually even let's say around 1700s is sort of a shift towards mechanization. So work starts getting defined in terms of machines rather than in terms of people, right? So this is when people need to find out exactly how machines work, right? So that necessitates like an sort of a precise, accurate physics of things, right? So that's kind of the ethos within which this calculus of motion is shaping up. But if you then compare that with what we have today, right? So today, I think, like there is generally growing consensus that we are sort of emerging into a new radically different technological paradigm, which is, sort of the paradigm of information, right? And so in a sense, there are like, I mean, a bunch of physicists and mathematicians who've in recent times who've started discussing and like working on the questions of the, like, just like, with the age of mechanization, we had a calculus of motion, or we needed a calculus of motion. Does that mean that with this age of information, we might similarly need a calculus of information, right? Now, what does a calculus of information mean? Well, I mean, it's still a work in progress. I mean, in like, with involving a lot of people. So we are yet to sort of, we are just seeing the beginning of that story. But there are various approaches. One of them is this David Deutsch and Chiara Marletto's constructive theory of information. So no one really knows whether this still this is going to be the theory or not, and that's not the reason why I'm mentioning this. But this is just an example of like multiple different sort of approaches that people are proposing right now, and these are all. I mean, they have. I mean, so these people particularly seem to be have certain initial successes with the approach that they're suggesting, but then we still don't know enough. Okay. Now, okay. So I don't want to go too much into this, but neither am I sort of technical expert on this. But I just wanted to mention that, like in the first slide, I had mentioned, like when we were talking about the social nature of mathematics, right? I mentioned that how it's a social cauldron, and I sort of mentioned sports and technologies and religion and so on. So here is an example of what I mean by sport, right? I mean, so this thing, I mean, those of us who are familiar with category theory or algebraic topology would recognize this. So this is called a typical sort of act of what is in algebraic topology, what is meant by diagram chasing, right? So basically, you like you sort of these are algebraic objects and with maps between them, and a large part of like sort of this sort of topological calculations basically involves what is called this diagram chasing, right? Chasing these kinds of diagrams and sort of trying to see trying to sort of gather information about the nature of the properties of these kind of maps and results, right? So here is a quote from Paulo Alufi's book which is called Algebra Chapter 0, and where he says, so proving the snake lemma is like, you can like, I mean, of course, like, I mean, we, like those of us who've kind of taken up like graduate courses in algebraic topology would have seen a proof of snake lemma, and it's not a nice proof. I mean, well, I mean, it's not a very enjoyable proof, I would say. But all of our teachers who sort of taught us how to prove the snake lemma and similar other like diagram chasing kind of activities, they would often say that, yeah, I mean, you'll never need to do this. You'll never, you'll not even enjoy it really. But like, it's just important to do it once in your life, right? I mean, it's kind of, do it, go home and do it, and like make sure that you understand it and never talk about it, right? I mean, that's kind of, we were, and when I was reading this book, this kind of really stuck out to me that, this is, I don't think what Alufi is writing here is an exaggeration, because I mean, this kind of matches with a lot of our own experiences. So Alufi writes that proving the snake lemma is something that should not be done in public, and it is notoriously useless to write down the details of the verification for others to read. The details are all essentially obvious, but they lead quickly to a notational quagmire. Such proofs are collectively known as the sport of diagram chase, best executed by pointing several fingers at different parts of the diagram on a blackboard while enunciating the elements one is manipulating and stating their fate. Right? So why I'm pointing this out is because we have like this traditional sort of textual notion of what doing mathematics looks like, right? I mean that, like it's kind of, you have to be like, you're like a Euclid, right? I mean, like you sort of have to write down every step and check every step, and like this rigorous and all that. All that is all right, but the thing is, that's not how everything happens on a day-to-day basis even with professional mathematicians, right? These are the kind of activities that makes mathematics a social activity, right? I mean, this pointing, a bunch of people pointing their fingers at a diagram on a blackboard and sort of, tracing something like a bunch of travelers on a diagram, right? I mean, it's hard to sort of convert that into a language of this mechanistic, algorithmized, what do you call it, this thing, rigor-based mathematics, right? I mean, that rigor part of it is often said that, you do it at home, right? You don't don't spoil this book. Anyway, so this is just the so this brings us back to sort of the question of the social core of science. So when we say science is social, this is sort of a quote from Richard Levins's article called "The Internal and External in Explanatory Theories." So Richard Levins is a mathematical biologist. And so he writes, at the present time, science is mostly organized as a knowledge industry. This means that its content, agenda, products have to be understood in terms of who owns that industry, who recruits and trains its workforce, who sets the problems, fixes their boundaries, and judges the solutions. What are the rewards and penalties for different ways of posing a problem? How is the product consumed, and so forth. So that's one way to think about how science is essentially social in nature. But I would also say that, but even more generally, our abstractions themselves, right, reflect our choices and values. So that's in a much more fundamental sense, science is social, right? So, and this again, this is from Levins, that the ideological and aesthetic preferences that guide the choice of models, for instance, right, are organized around three principal axes: responsibility, intelligibility, and controllability, right? So these are all choices or values that we make, right? So that's what I really mean by when I said, like, I mean, the social nature of mathematics. Okay, so that brings us to sort of the core part of the presentation, which is the particular sort of microfinance model that some of us have been discussing or trying to understand. So this is the paper. It's titled Mathematical Models for Microlending. So here is how it. So let me just like quickly run you through what's happening in this in this piece of mathematics, right? So the first of all is the setting up of the puzzle. In other words, what are the starting assumptions? So one of the assumptions that these people make in the paper is the assumption of stochasticity, right? That like this microfinance, I mean, this kind of debt relations are stochastic in nature, right? I mean, so you have a bunch of borrowers, and so it's kind of modeled as a random system, right? As a stochastic. But if you think about it, this assumption of stochasticity makes sense only when the world is looked at from the point of view of the lending institutions, right? Not from an individual borrower, because for an individual borrower, it's absolutely not a random situation, right? For an individual borrower, it's a fairly deterministic situation. So this means that we are basically rationalizing the political economic asymmetry between lenders and borrowers, and then we are reproducing it by coding the asymmetry into the mathematical model itself. This you can go on like dissecting the paper, right? So one of the points, for instance, one of the things that will strike out to you is how, I mean, they sort of mention this. I mean, while they're trying to formulate their model, they sort of assume that if a borrower has okay, so first of all, a borrower, let's say, has borrowed some money to invest in a business, and once the business is successful, the borrower will pay the money back to whoever she borrowed it from. So in the model, you won't find any uncertainty, although it's a stochastic model. The uncertainty doesn't lie in that step of going from a successful business to paying back the loans taken for such a business, right? So in other words, the modelers are assuming that if the borrower is successful with her business, then she would of course pay pay back her debts. So this is not a mathematical assumption, right? This is just like a model assumption. This depends. This heavily sort of depends on this obligatory nature of debt, that if you have borrowed money from someone, you need to pay it back, right? And then there is the assumption of memorylessness, because they want to use Markov processes and Markov chains and so on. So which basically, and memorylessness in this case, of course, means summarily ignoring the social memories of radical inequalities like labor, caste, gender, and so on. And then you find, again, the Newtonian assumption that currencies are just an algebraic convention that comes back, right? So, and they actually say that the actual currency used is irrelevant. This is a total disregard for the central role of state and market institutions that play in propping up any given currency system. So in other words, a currency system is not just an algebraic convention. It's actually much more than that. And then there is the assumptions like the system of microfinance is ultimately stable. That's basically because the mathematical model itself has limiting states and so on. So anyway, so one of the main things I wanted to sort of talk about here, by the way, can I switch off my video for just for a while. I'll try to put my phone on charge. I didn't expect to use my phone, so it's running out of charge. Or, oh, you don't have my video on this, right? Hello?
Yeah.
Yeah. I mean, so like, just give me a couple of seconds. I'll just plug
Yeah,
in
sure.
plug in a charger to my phone.
Okay.
But it switches off. Yeah. Hello.
Yeah.
Yeah. Okay. So the main thing I wanted to sort of focus on this, however, is what is called the utility function, right? So somewhere down in somewhere there in the model, they talk about sort of this thing called the utility. This involves like basically this means decisions involving trade-offs among costs and benefits that are occurring at different times, right? So this is like the decision making process, and so here is sort of the mathematical formulation of that, right? So this is sort of it's basically an expectation calculation. We don't have to get into sort of, this is like, you can see, I mean, this is basically what is called the expected total discounted future income, right? So this is basically how someone estimates their future income. Now, we don't have to get into the details of this, but I just wanted to focus. I mean, if you look back into the model, I mean, you'll see a delta, right? I mean, I just wanted to sort of talk a little bit about what that delta represents, right? And how this this variable actually encodes an entire model philosophy. What is this delta, right? So this delta is what is called the time discount factor. In other words, it's a token measure of the borrower's psychological motives, right? I mean, in a sense, what it measures is the following. So capitalism has kind of this timeless moral puzzle, which is that why do people or economies of nations not allocate their labor for production of capital, right? So that what that means is that if you have some amount of money, why won't you invest that money to sort of make profits out of it, right? Because otherwise, basically what you're saying is that you're willing to take that loss, right? So if you're not investing the money for a higher profit, that means you're actually losing something, right? So that's what this refers to, and so that's what this delta is supposed to sort of measure. And this sort of was first proposed by Paul Samuelson in the 1930s in this paper titled Note on Measurement of Utility, where he says that in this note, a possible alternative method resting upon different assumptions is presented, not so much in the hope of furthering inductive investigation in these matters as of bringing out certain theoretical relations between the variables under consideration. So he's basically talking about this time discount factor. So it's just it's nothing inductive. It's nothing like it's nothing scientific in a sense, right? I mean, it's just a theoretical construction. But the question is, why is it a puzzle at all, right? I mean, why is this a puzzle, right? I mean, and modern economists have, I mean, even till today, I mean, like modern economists have been sucked up into this struggle, ranging all the way from Adam Smith all the way to Samuelson himself. But why is it a puzzle? Well, it's a puzzle because of an axiom that Adam Smith assumes, which is to say that national wealth was determined by the amount of labor allocated to the production of capital. I should mention here that capital is different from money, right? Capital is money that can grow, right? I mean, so capital is not the same thing as money. So when Smith is saying that, national wealth is basically a product of capital, what he's saying is that that's the normal thing to do, right? I mean, that's the normal way in which wealth, that's almost for him the definition of wealth: accumulation and maximization of profits. These are the normal things to do. And the natural state of any money, any amount of money, is to earn compounded interest, right? So that's kind of, so this is of course connected with the economic characterization of what is famously called the Homo economicus, the rational economic man, which is in a way very similar to sort of Robert Boyle's ideal gas, right? I mean, so you can take like this Homo economicus character and sort of simulate them, right, in a mathematical model, and sort of convert everything into an optimization problem. Okay, so, and then soon enough, anything that is non-capitalist, any non-capitalist mind, quote unquote, becomes defined as pathological, right? So John Ray, for instance, argues how things like social and benevolent affections, intellectual powers that cause self-restraint, habits of reflection and prudence, uncertainty of human life, excitement produced by the prospect of immediate consumption, these are the kinds of factors that limited the effective desire of accumulation. But if you look at those factors, these are exactly what human beings do, right? I mean, so basically, a human being is pathological, right? I mean, that's essentially what it boils down to. And we can see that in our debt model, and that's why I mentioned this, that you can see in this model how actual people, the borrowers themselves, are reduced to passive Newtonian objects merely responding to the forces of finance and play. And then they go on to sort of model this fear and shame, and like, I'll not go into those details here, but like the purpose of introducing a period of, I mean, this is a quote from that paper. So they say that the purpose of introducing a period of loan exclusion, so based on this time discount factor, etc., they come up with a punitive policy, right? I mean, basically, if someone doesn't pay back their debts in time, then they're blacklisted, right? And they don't have access to loans anymore, right? So that's kind of the penalty, right? So they calculate that penalty, right? So, and while doing that, they say this, that the purpose of introducing a period of loan exclusion is to avoid any incentive to default by creating some fear of being excluded of the right to get a new loan. So this is kind of, this is mainly, some comments about that money lending model, which brings us to the question of economies of endless repetition. So I'll just, because I think I already lost a lot of time also in like these technological things. It's only fair, I think, given that whatever I've been trying to talk about. Anyway, so here are some, I'll quickly rush through this. So here are some of the features of what economies of endless repetition, and if you are trying to, if you want an example of an economy of repetition, then like just think about today's, like take any big city urban economy, whether it's Hyderabad or Vijayawada or Delhi or Calcutta or Mumbai and so on, and that would give you a sort of sense of what I mean by that. So one of the, like, so I'll just quickly rush through. I just tried in these slides, I kind of try to list down some of the core features of this. We can come to some of this during the discussions. So one feature is applying numbers to material questions, and which of course produces the well-known tension between representation and omission. One example of what this means is, again, we can get into some of this during the discussions, but one example of what this one example of how what this means and what this leads to would be to study the pandemic models, right? I mean, this is also something that we're studying, and maybe sometime in future, hopefully we'll get to talk about pandemic models in more details, but that's an example of this. Another feature of these economies of endless repetitions is what we might call totalization, right? Or what Newton himself called the system of the world. The assumption that this mathematical model as a representation of some aspect of nature abstracted into a form that could be manipulated, extended, and solved, right? So it can be extended across various different contexts. So that's why we see, like there's people, these kinds of, sort of intellectuals moving seamlessly from what we might call enlightened science to risk management, right? So this is like, I mean, this examples range from William Petty's. Petty is like around the same time as Newton. So William Petty's political arithmetic to our today's in our current times, Jordan Ellenberg's what he calls electoral geometry in his latest book called Shape. Okay, so this totalization is another aspect of these economies of self of endless repetitions. A third aspect that I wanted to sort of list out is what we might call the horror of the infinite, right? So again, I'll rush through this. Unfortunately, we don't have enough time, but like basically the point here is that it took people a long time to sort of warm up to the idea of the infinite, and but I mean, so this includes the ancient Greeks and so on. I mean, like people were never really comfortable with infinity, with notions of infinity, because like they kind of it was hard to find a logical philosophical basis for justifying such things. But one of Newton's main contributions, which is often quite overlooked, is that Newton did not, when he was trying to do calculus, right? When he was trying to do infinitesimals, trying to work with infinitesimals, the main break that he made from his predecessors was that he refused to get into sort of this metaphysical tangles about what does infinity mean and so on. He converted infinity into basically a nominal thing and put it to work, right? But what that has led today, I don't want to sort of say that Newton is responsible for all of this, but every time I'm talking about Newton, I'm just trying to sort of take up sort of a well-known example. But this is absolutely not just like this one person. I mean, those things are often work, right? I mean, but I mean, this is just a representative of the historical processes that we can talk about. But I mean, if you sort of go through time and reach today, what this infinite economies have done is like, I mean, this kind of this idea of capital that can grow infinitely, right? This idea that we can grow infinitely, right? This 5% GDP increase every year, right? I mean, this infinite growth, compound interest, infinite profits, right? What that has led to is this, right? I mean, so this is sort of the carbon dioxide levels in the atmospheric levels of carbon dioxide as modeled or simulated since the ice ages, like since and you can see how you can see what happens post around this time, and this is 1700s. This is the beginning of industrialized capitalism, industrial capitalism. So okay, so another aspect of this economies of endless repetitions is what I was just now referring to, which is like putting things to action, right? This thing of this kind of mechanical pragmatism. So Newton, I mean, this is what I was trying to quote earlier, that Newton didn't linger in the tangled metaphysics of a nothing that wasn't quite nothing, right? I mean, like here, Levinson is talking about infinitesimals, the idea of infinitesimals. Instead, he put it to use, right? So this kind of the spirit of like this kind of almost an explorer or adventurer's, sort of spirit of putting everything into action, even if we don't really understand it, right? This ties together with like the generally, I mean, like kind of the Newtonian geometry, like how like he proposed that a curve should be actually seen as something that evolves out of an equation and so on, because like earlier it was the other way around. Earlier people wanted to thought of curves as solid total things in themselves and equations as sort of a feature of that of such a curve and so on. Anyhow, so since we are actually quite out of time, let me and then I talked a little bit about stochasticity and determinism, so I won't go into these details. One example of this stochasticity is this kind of this third wave, quote unquote, that we are all waiting for, which feels like a prophecy almost at this point. Okay, so and then these are sort of some other features, which is like, but a collection of variables is like this kind of this social governance as database management, right? So this practice of converting people into a bunch of variables, right? So as if our bodies, I mean, our existence, human existence is basically a bunch of finitely many variables, right? So all of these can be like these can be historically traced all the way from what's going on in sort of what we call early modern, or what I think should be more correctly justifiably called the beginning of capitalism. And then one of the central aspects of this is how all of this linearizations, the role that they play in hiding power relations and what we can call as radical inequalities, right? Radical inequalities means inequalities like gender, caste, race, labor, and so on. Basically, social relations that are radically unequal in the sense that your usual sense of reciprocal exchange break down, right? So you don't have the usual notions of this, usual relations. So anyway, so our debt model was an example of this, because the borrowers that they were talking about in that model are basically women borrowers who are subjected to this kind of patriarchal money lending model. I'm going to talk about this later in the discussions. This is something about like complexity theories, but let me not get into that. Yeah, so that brings us to the final part, which is sort of the great divide, right? So here are some of some of the fallouts of all this. This doesn't happen, this is not just like theoretically happening, right? This is happening on people's lives and society, right? So these are some of the fallouts of this, right? What is like the kind of divides that are setting in, the kind of tearings that are happening, right? So people are torn from their lands, individuals are torn from their social relations, texts are torn from their contexts, humans get torn from like nature, labor gets torn from people's bodies, work gets torn from creativities, values get torn from meanings, and so on, and so on, right? So that's what I mean by, this, by the way, this might be a usual, a familiar picture of this Amazon forests and the clearing of Amazon forests that's happening for decades now. And then something that we learned from the pandemic, called the metabolic rift. This is not a new phrase. This is a fairly old phrase. But metabolic rift in this case refers to sort of the tearing apart of our economies from our ecologies. This is one of the things that we learned from the pandemic. But again, okay, and then the final question is then, is mathematical, if there is a divide, what is the role that mathematical models are playing? Are they a bridge? Because oftentimes that's what we are told, that they are to have mathematical models that can talk simultaneously about economics and ecology. So what are you complaining about, right? So the question I wanted to raise is whether they are a bridge or rather a giant pair of scissors, right? And again, there's a lot that should be talked about this, but let me go off to the last part of the presentation, which is to say, how do we then think about, given all of this, what does this tell us about the question of mathematics education? So I wanted to sort of bring back the question of mathematics education to the questions of care and freedom, right? What this means is that, what happens if we begin to think of education as as part of the process of making people rather than making things? This is what people call as social reproduction, which involves, first of all, redefining the value of work, right? Because what is the usual reason we hear everywhere as to why learning mathematics in school is important? Because otherwise people won't be employable, right? They won't be able to work productively, right? So this basically means we have a particular definition of what valuable work means, right? And basically what I'm trying to say is that I don't think there is any rescuing the question of education if you are not willing to redefine that value of work itself, right? What do we mean by valuable or meaningful work? Can we think of science work as humility rather than arrogance, right? Because science, a large part of science, and in fact a central part of science, is the, I would say, is the ability to be wrong, is the ability to be to be mistaken, right? Can that form a basis of a science that is based on humility rather than arrogance? Can we think of learning as collectivities of social relations instead of an individual person and an individual text, right? Can we think of education as care work rather than a service? And what do I mean by care here? Care, a kind of care, the kind of care that leads to freedom. So for instance, even the prison authorities provide food to the prisoners, but we don't think of that as care, right? So because that doesn't lead to freedom, right? So care that leads to freedom, and freedom in turn that is realized in caring for others, right? Anyway, so let me stop with that. Yeah, let me stop with that. Sorry for all the technological. This is why I generally avoid like online presentations. Really bad with this.
Jesse is not here. So how Jesse is not here, it seems. Ah, he's there. Yeah. Hello, Jesse, are you there? Hello?
Just we can continue if he is not.
I'll kind of coordinate the questions. So thank you so much, Tata, for this talk. It's actually kind of quite, what should I say, exciting at one level, and also is pretty challenging for those of us who might actually have some kind of an engagement with socio political concerns. And for how to connect mathematics with all this is actually quite an interesting challenge. I think this is a beginning, and probably this would really lead to something very, very interesting and useful for all of us. I really look forward to it. Now, I think there will be there are probably questions from others, and I'd like to, yeah, please, if anyone has a question, please. Maybe you can put your hand up, or you can type your question in the chat.
Yeah, you started saying something about pandemic model and then you didn't continue. So could you elaborate a bit?
Suratna, yeah. Could you hear him? Tata, could you hear him?
Yeah, I could. I have.
You are muted though. I think he muted, I think.
Tata, you're probably
Hello.
muted.
Hello.
Yeah, we can hear you.
Hello.
Yeah, we can hear you. Hello, Tata, we can hear you.
Hello. Hello.
Yeah.
Yeah. Sorry.
Yeah, it was not a
I
real
was-
question. You said something about pandemic model, but didn't elaborate. Just that's what I'm asking. Can you?
Yeah. Yeah. Sorry, I'm still kind of juggling around with my charging and stuff. My phone will die. Basically, what I meant was, it would take a longer discussion talking about pandemic models. But the main point was that, let me go back to that slide. I mean, my main point, however, was what happens to sort of when we try to use mathematical, like, because we know numbers, right? I mean, so we tend to sort of use numbers based to model material situations, and I meant pandemic model as an example of that. But the main point I was trying to make through this is, like, the impact this has, right? So one of the issues of this, for instance, is that we use the hello.
Yeah, we can hear you.
Yeah. Just give me 1 second. I'll log in from another phone. It's like showing
Sure.
1% challenge. So sorry. I'll just 2 seconds. Yeah. Sure.
So you're going to log out or log in?
Hello.
Yeah. So we are able to hear you.
Great. Okay, great.
Yeah.
Good. I feel relaxed now. Okay.
Yeah.
Yeah. Okay. So the thing about pandemic models is that, so the main point I wanted to make is, first of all, I mean, so this is, there is no, per se, there is no problem in using number systems to make sense of pretty much anything that is, material, quote unquote, right? I mean, because that's what we do, right? I mean, so like, here Richard Levins is saying that we study the unknown by making believe it is just like the known. In other words, what else can we really do? So, but the issue is different. The issue is that how much, I mean, because, numeralizing something does two things, right? I mean, and there is a kind of tense relation between these two things, right? On the one hand, numbers help us represent certain aspects of reality, but at the same time, and precisely because of that, they also omit other aspects of reality, right? So there is this classical tension, and it's unavoidable. I mean, it's kind of, part of the game. Now, the thing is, if you look at the second quote here, I'll go back to read. So here, Levins is saying that, that the fact that this numerical idealized reductions is unrealistic is not of itself a devastating criticism, right? We also abstract away, like, let's say, fiction from perfect test models and so on. But so when it comes to markets, for instance, right? So if markets are never perfect, and if furthermore they deviate from perfection in ways that serve their owners and become less perfect as the power of corporations, for instance, increases, then that abstraction that we are talking about is not only unrealistic, but also actively obfuscating, right? So that's the issue. So when it comes to pandemic models, on the one hand, we've been using all kinds of, like, linear algebraic models, stochastic models to try to understand the pandemic. So that itself is not an issue. But the issue is whether, like, how much of the reality of our, of public health in this country, for instance, right? What we saw during the second wave, right? I mean, people literally dying from not being able to breathe, right? And and like extensive parts of the country with absolutely no public health system, and like villages where people don't even have paracetamol tablets, right? I mean, so how much of that reality gets, first of all, gets omitted from these models, and in turn, how much of obfuscation do they produce? So that's kind of the to cut a long story short. And I also wanted to add that, like, so another kind of curious thing, if you notice, that kind of happens through this, for instance, is that, what happens during these economic lockdowns, right? Because, like, somehow, although we are using the same kinds of mathematical modelings to model both our health realities and our financial realities, they are predicting two completely different things, right? So the mathematics that we are, like, our mathematization of the health realities is suggesting that we need to shut down the economy, right? We need to sort of import, implement lockdowns and so on. However, our mathematical models of our financial reality tell us that that's an economic disaster, right? So basically our financial rationality and our health rationality have come to in conflict with each other. How does that happen, right? Why, even when we are basically using the same paradigm of mathematics to understand both. So I think, like, I mean, it can be, so that conflict can be traced back to these obfuscations that there is. I don't know if that speaks to
I
your
got
question.
I
Longer.
kind of got, yes.
Okay.
Yeah,
So-
some of these modelers are even predicting what is effective lockdown. They're even saying how much lockdown. So
Yeah.
yeah.
So, anyone else?
So, yes, so that being said, like that, the economic disaster and the health disaster. So, how do you measure the purity of a model? Because that's what should be the main concern. That
Sorry, how do you measure the
purity of a model?
Purity.
Yeah, like purity.
What do
Like,
you mean by purity of the model?
yeah, that's what should be made precise, that it should not be biased towards certain thing.
Yeah, I mean, that's right. I mean, so that, and I think like, so that's definitely there, right? I mean, so how we need to constantly guard ourselves, or constantly alert ourselves to how, in which possible ways are our models becoming or imbibing bias. Now, and that's part of like that's actually really part of like the day-to-day work of a scientist or a data scientist or and so on, right? I mean, that's part of the job description. And so, and I don't think there is a silver bullet there. I mean, I don't think there is one sort of universal way to sort of ensure that we are always guarded. We are, skeptical enough. But the issue, I would say, is not exactly there, right? The issue is what I'm trying to, like, for instance, what this slide is trying to say, right? I mean, that the issue is not exactly internal to the model, right? I mean, the issue is about what's happening in the rest of the world, right? So let me actually, maybe I should reason to go to that other one that I absolutely skipped over. Yeah, this right. I mean, so I mean, so some of the current state of the art approaches to these kinds of questions is complexity theories, right? I mean, which are basically based on a recognition that the long traditions of reductionist science are increasingly inadequate sort of cope with systems that we are now trying to understand and influence, right? So here's, like, I mean, for instance, again, a quote from Levin's paper. He talks about how, like, pesticides seem to be increasing pest problems. Antibiotics are actually creating new pathogens. When you look at sort of the potential area of hydrocarbons, it's kind of famous for this, superbugs that are it's a pharmaceutical town, and sort of the kinds of new pathogens that are reportedly getting produced in the ecosystem. Hospitals are foci of infection. Food aid may increase hunger. The straightening and taming of rivers increase floods, right? Economic development does not necessarily lead to equitable just societies and so on. So, like, I mean, these are kind of, so there is a certain kind of realization, I think, that, like, this is not working, right? So, and one of the approaches that have been proposed is complexity theories, which is not a bad start, right? I mean, because these are some of the things that complexity theories, for instance, these, I don't know, I mean, these are, I would say, are some of the, like, more sort of like safeguarding recipes, like, kind of learnings, right? I mean, so for instance, this recognition that, the truth is the whole, right? I mean, then the fact that parts are conditioned and even created by their wholes, right? Then things like things are more richly connected than is obvious, or that no one level of phenomenon is more fundamental than any other. Each has a relative autonomy and its own dynamics, but is also linked to other levels. And then the fact that things are snapshots of processes, right? So that and so how do you understand, what do you mean by processes and so on? And then the dichotomies, the usual dichotomies that into which we split the world, right? This biological versus social, or physiological versus psychological, or random versus deterministic, etc., are misleading and eventually obfuscated, right? So, so these, I would say, are progresses, I mean, in a sense. But then even at the end of all this, the question that still remains is that where is the rest of the world, right? Because if you're talking about, like, these kinds of complex systems, that is sort of the constant, the one question that needs to be asked every time we see some model that seems to make claims about complexity of the world, that in any complexity model, we need to ask, where is the rest of the world? So that's what I meant earlier when I said that these questions are a lot of times located not exactly internally to the mathematical models themselves, but are external to it, right? So my point is not about, like, good models versus bad models. I'm not very interested in that. I mean, like, there are bad models, yes, but and there are ways to sort of make better models, right? So that's not the issue that I'm trying to get at. I mean, I'm not trying to, I'm not saying that, the main thing is to have better and better models. But main point I'm trying to get at is that the whole world does not run on mathematics, right? So this assumption that we will eventually be able to come up with this kind of a total mathematical system of dealing with the world where finally there will be no outside of it. I don't see any scientific reason to believe in such a program. And if that is the case, then how do we locate mathematics as a knowledge system in that larger matrix of human knowledge systems? And that's where the question becomes social, political, economic, and all of that, right? So, and it's kind of one thing that I tried to sort of point out through this presentation is how these questions are almost inseparably interlinked. And they begin from the very fact that this mathematics that we are doing is itself a product of these social processes and not external to it, right? So,
okay, if there are no more questions, this is going to be a long discussion, and I think most of us are in the beginning of this, and I think Tata himself is also saying the same. And so I would say that, there's also another talk that we are all, we have to go forward. So unless there are some more questions, I would like to close here because it's nearly 20 minutes out beyond our time. But if there is a pressing question, certainly go ahead.
Well, in that case, let us thank Professor Tathagata for speaking with us and explaining many things. And we express our appreciation to him, and we'll close the seminar. So thank you very much, Professor Tathagata.
Thank you.
Okay.
Yeah.
Well,
thanks.
very interesting.
Over in between.
Bye for now. Bye-bye.
Bye. Yeah. Bye. Yeah.
Thanks, Tata. Bye then.
Thanks. Bye. See you.
Yeah. Bye.
Bye.
Yeah.